Welcome in to another new NACE International podcast. My name is Ben Dubose, and I'm a staff writer with Materials Performance Magazine and with Coatings Pro Magazine. Today, as we continue our MP interview series, speaking to various leaders within the industry, we're joined by Alexander Murillo, Technical Service Engineer at Belzona. Established in 1952, Belzona describes itself as a global leader in the innovation of repair compounds and industrial coatings. Alexander, good afternoon. How are you?
Good afternoon, Ben. I'm good. I'm good here in sunny, rainy Miami. But happy to be here. Happy to be here and just talk a little bit about first of all corrosion and how we're involved in it. Basically,
Yeah,
right?
and I think a good place to start, Alexander, for our audience that isn't aware of you before listening to this, tell
Okay.
everyone about your position, your background in the industry.
Okay.
For example, I know you're a NACE coating inspector, level 1 certified. Just talk a little
Yes.
bit, if you could, about your current job and your areas of expertise.
Okay. So I'm a chemical engineer. I have a BS in chemical engineering. I'm also a chemist, and I joined Belzona a little over 5 years ago, and basically jumped right into it. I had experience before with actually heavy machinery. So I did see different types of alloys used to counter corrosion, but I was never really involved in it until I got to Belzona.
Mm-hmm.
Once I got into Belzona, I literally was thrown into the whole corrosion, erosion, and wear industry. And basically started that. Some of the basic things that we do, and this is just everyday things, is just support to our customers in all their needs, usually heavy industry. We usually work mostly in heavy industry, very little in commercial. Support on any of our products. We do field support a lot, phone support. We do, of course, emails, and those are the basics. Then we do trainings. We do field trainings a lot of times. We go and help supervise jobs, all different types of jobs. Here in Miami, we take care of all the Americas, so it's North, Central, and South America. Mm-hmm. So we go all around those countries for specific training. Like say, we do different field trainings for different types of application techniques, be it coatings, be it wraps, be it spray, be it flange face, be it whatever the situation requires, right? We do that, so we're in constant contact with, first of all, our distributors and our consultants that are directly in contact with the customers, of course. And then in this case, a lot of times we're in contact with a lot of inspectors, NACE inspectors during jobs. So it's a flow of everything. We do investigation. Also, we do research and development with R&D to look at new products or upgrade new products or look at new techniques or new problems that are coming up and trying to find out solutions for them, right? So we do a little bit of literally a little everything. We're also well connected with our marketing team. We work very close because marketing and social media right now, it's very important, right? It's very important to get your message out and to get the correct solutions out. And let's limit as much as you can the broken telephone type of service, right?
Yep.
And then that's it.
So, as I mentioned earlier, Belzona specializes in repair compounds, industrial coatings. For anyone that's unfamiliar with Belzona, prior to your explanation right there, where exactly do you all fit in within corrosion control? What are the different types of corrosion that Belzona materials might be able to address?
Okay, so corrosion across, the whole spectrum of corrosion problems. I think the only limitation we'll have is there are organic coatings, so we have a temperature limitation. Mm-hmm. And we could only resist a certain temperature, and then certain times certain chemicals. Some chemicals are very aggressive. But we, first of all, like you said, 1952 is when we originally came out. We're actually a global company. We have about 140 different distributors across 120 different countries, Asia, and we have 5 corporate offices, and one here in the U.S. We have one in Canada, in the U.K., China, and Asia Pacific. So we have corporate businesses, and then we have satellite distributorships everywhere. And out of these offices, we work with all types of corrosion. Just starting from the basic general environmental corrosion, your basic iron wanting to be back to iron oxide type of situations, right? Then going into corrosion under insulation, microbial corrosion, bimetallic corrosion, chemical attack, which in a way is a type of corrosion because it's in certain environments,
Right.
almost any alloy can corrode, right? So and then corrosion, which it's always worse. Cavitation, we look into it also. Even though you wouldn't say it's corrosion, it's part of the industry. It's part of the system, right? It's part of the wear that you have, right? And a combination of all these words is always worse. Abrasion, any other type of corrosion that you could think of, we probably address it, right? There's corrosion in itself is a whole semester of study, just for a couple of corrosion, some of the basic corrosion problems. But we cover literally as many corrosions as there are out there, and each situation comes up is sometimes a little bit different, right? We come up with different things because we cover such a wide range of industries.
So I'm looking at your bio, and I know you've
Okay.
worked a lot within the power industry, spray application, composite wrap repairs.
Okay.
What are some of the common problems with those types of assets as it pertains to maintenance? Or I
Okay.
suppose a better way of phrasing it, when clients in those sectors reach out to you guys, what are some of their concerns?
Okay. So and this is really across all industry. You could see the same issues across different industries. They're just different situations, right?
Mm-hmm.
So let's take, for example, power. I work a lot with power. You have coal, you have hydro, you have gas, you have biomass, you have wind, solar, nuclear, geothermal, and just general fossil fuels, right?
Mm-hmm.
For example, coal, which is, and this is no surprise to anybody. Coal is, it's coming down. In the last couple of years, they've closed a lot of plants down, but coal's a great example where you have a lot of abrasion, you have chemical environments, chemical processes as part of the process, and the tanks, the substrates, they'll just corrode naturally through that. Hydro, you have generic corrosion, especially in places like basically in your penstocks, in your piping. Erosion happens consistently in hydro. Gas is one of the cleaner ones, but you still have general corrosion. You always have chemicals, and you have chemical containment. You have tanks, and over time, sometimes, let's say, things don't come out the way you think they're designed. A lot of times, you have bimetallic systems that weren't planned, and corrosion happens there. Corrosion happens a lot in welds. Welds are especially prone to corroding easily. So, and this happens in all these types of instances, right? Biomass. You have microbial corrosion. For even in wind. In wind right now, we've gotten very strong in wind and leading edge protection. It's a type of environmental corrosion erosion, right? That basically damages the the leading edge on the wind turbines and can actually bring down the efficiency of the turbine to about 20 to 30%, right? So you're losing a lot of money there. Fossil fuels, burning of fossil fuels, of course, that's always going to give you just an excess of different types of environments that are very corrosive. Even when you don't think about it, even the fumes that are coming out of your basic processes are actually coming out and going onto all your different metal substrates or your structures, and those corrode. So corrosion happens literally from every level of a plant. I mean, there's usually no level that's safe from corrosion, right? And let's say alloys and top of the line alloys are very expensive, and
Right.
it's not feasible to be able to alloy a whole plant. And this is where we come in, and we find solutions for our customers. Our motto is really repair, protect, and improve, and we really believe it. First, we normally repair whatever issue you have. If you have pitting, if you have loss of metal, with one of our paste grade epoxy products, then we protect it against whatever corrosive environment it's in. In this way, improving the process, right? That's our motto, and that's really what we do. We improve the process, try to save the customer money in the long run, and save the customer basically the asset in the long run, right? So, I mean, it's no different than what else we actually see in other industries, right? In chemical process industries, in wastewater. So corrosion is everywhere, and it really depends on usually the chemicals that are being used. Like for example, in oil and gas are a little bit different than you would use, let's say, wastewater. But corrosion is going to happen. It's going to happen. It's going to affect your assets. The process affects your assets, and that means downtime.
Mm-hmm.
And downtime literally means loss of thousands, sometimes millions of dollars.
Yep. So we mentioned earlier your chemistry background.
Mm-hmm.
Let's talk about materials. Because
Okay.
Belzona's solutions, I mentioned broadly repair compounds, industrial coatings. If you
Okay.
could go into a little bit more depth about the technical side, what
Okay.
are the features that these asset owners need? In terms of the
Okay.
chemistry of all of this, what are the types of features that Belzona's solutions typically have or that you're trying to develop?
Okay, no problem. No, we haven't developed basically, right? So we have our main line of coatings, and we call it, we don't call them paints. We're a coating company in a way.
Mm-hmm.
Are epoxy resins, right? Epoxy resins, they're long chain polymers, but they have a specific properties. Epoxy resins, once you engineer them, you can make them very rigid and very tightly bound, if you could say that, right? So they're going to give you certain properties that are extremely good. They're going to be very tight, so chemicals are not going to pass through them very easily to your substrate. Also, our epoxy are 100% solids, right? So a lot of times when you have coatings that are not 100% solids but have solvents, you end up having solvent entrapment, and you have voids. And through these voids, a lot of times the chemicals or liquids are just aggressive corrosive environments go to your substrate, right? So having 100% solid is extremely important. Another thing that epoxies have is that they have a high heat resistance for being organic, right? So the epoxy technology lets us use the epoxy chain, add different functional groups of organic chemistry, and basically tweak our epoxy system to what we want in a certain solution. So if we want high heat in a certain solution, we might make it extremely tight, very little fillers. We're just looking for tight, thick, tight system where it's going to resist heat and chemistry, right? If you have a system that your problem is corrosion, but it's also erosion, we might add different fillers to give that the erosion resistant. In the past, we've used ceramic fillers. Now there's something new called thermoplastic fillers. These thermoplastic fillers, what do they do? With ceramic fillers for large areas, you end up when you want to do a large job, it's much more feasible with a spray application, right? Ceramic fillers usually eat away the spray material, or the spray, the pump, and basically the whole equipment, right? So new thermoplastic fillers give us the options to actually do spray jobs for erosion-resistant systems, right? So mainly it's epoxy coatings and epoxy rebuild materials. We also have a line of polyurethanes, right? Polyurethanes it's a little bit more flexible, so we adjust to whatever situation we have, right? Conveyor belts in the mining industry, a lot of times, rollers, they're all made of rubbers. So we try to help repair and protect some of those issues, right? But the polyurethanes, what are they going to give you? They're going to give you more flexibility, but of course they're not going to have the same heat resistance and chemical resistance. So like it's like everything. You have a little bit of something better on one side, but you lose something somewhere else. So you just got to find a balance of it, right?
With over 37,000 readers, Materials Performance is the world's largest circulation magazine dedicated exclusively to corrosion prevention and control. Published monthly by NACE International, Materials Performance covers the latest technologies, techniques, and methods of corrosion control used in industries and infrastructure worldwide. Sign up for your subscription today at materialsperformance.com/subscribe.
So let's switch gears and talk about the application of those types of materials.
Okay.
Because I know you have sort of a unique role in terms of what Belzona does from an oversight perspective. You touched on that earlier. What are some of the keys to applying those types of materials successfully? And feel free to share some of your own experiences as you sort of answer that topic.
Okay. I mean, I think we here at Belzona, we believe we're at the high end of the coating spectrum, right? And we're very strict with our requirements. And talking to NACE, of course, number one on our list is surface prep. You can have the best product in the market, the most expensive, But if you do not have good surface prep standards, it's not going to work out, right? It's just not going to work out. So number one is surface prep, and then once you have a good product and you have the right standards, you're going to need logistical advantages. For example, I'll give you an example, and this is how we help solve a problem for, I don't know if you've heard of Barrick Gold. Barrick Gold is one of the bigger gold companies in the world. They have a mine in Dominican Republic. It's called Pueblo Rico mine. They had an issue, right? First of all, getting into these mines, it's really not easy. It's not easy. Sometimes I think it's harder to get into certain military. It's hard to get into certain military facilities than in these mines. They're really strict with it to get in there. We got in, and they had a very unique issue, right? So they had a big tank. The tank was about coverage rate was going to be somewhere around 9,000 square feet to be coated. It's actually a slurry neutralization tank. It's part of the process of purifying let's say the ore and getting the different minerals out of it. But they had a couple of problems. Number one, they had general corrosion in the system. The slurry tank worked at 160 degrees Fahrenheit. They needed something that could take the corrosion, take the chemicals in there. It was a little bit acidic, and there was microbial corrosion because there were microbes in there that basically ate the sulfide and caused horrible corrosion in the system. Another problem is that it was slightly acidic, and you had the ore erosion. And then high temperature. So they really couldn't find a solution. They were looking for a solution, but anything they could find was only brush applied, right? And the problem they had is that they only had 20 days to do it. So they were looking for a material that could do it in 20 days. So that means that it had to be sprayed applied, right? So you see how you end up having you might have a great product, but you need the logistical advantage to be able to apply it correctly, right?
Right.
Another problem is that at the actual site, it's a humid environment, so you're always having flash rusting after you're doing your blast. So you need to get it done as quick as possible. Anytime there was actual lightning, all work had to be stopped for 3 hours. So the logistical challenge was, okay, you have a great product. You have a product that's going to meet your conditions, your temperature conditions, your erosion conditions, your chemical resistant conditions, right? But now how do you apply it within 20 days with having all these issues, right? And being able to spray it was very important. And that's why I told you having these new technologies and being able to spray the product was able to help us meet their downtime, right? Those 20 days, and within stops and continuing the actual application, we were able to do the application in literally about 12 or 13 days, which if they would have had to do by hand, it would have been impossible. So even though you have the great product and you have the technique, you need to be able to have the actual technique to do the right application, right? And in this case, it was spray. And that actually got us that one tank. And I actually spoke to the consultant today, and it's in perfect condition. It's been there for 4 years. And he's already done about 6 or 7 more tanks, right? Yeah. Not only because we had the good product, because first we had a good NACE inspector there that helped keep all the standards for surface prep. You had the product, and then you also had the machinery to do the product and the personnel that were trained to do the product. To do the application correctly, right? And like with any job, I think with spray applications and almost any job, it's all about logistics. You have to have the correct logistics, the people that understand the logistics for a job to go down smoothly. Of course, always maintaining the correct standards, the correct surface prep standards, because if there's not correct surface prep standards, you're going to end up having a lot of issues down the road, right? So that's one example with. And that was done with our high temperature erosion corrosion coating. And then other examples that we've done, for example, composite wraps. Composite wraps are actually big in the industry, especially in oil and gas. We have a system that it's ASME, ISO standard. It's compliant to those standards. And the system itself brings piping back to standard. A lot of times you have internal corrosion in piping, and the processes don't stop. The process just keep on going. You really can't stop the process.
Sure.
So there are corrosion studies done to see how the pipe is in certain areas. Once the pipe has lost a certain amount of material, you need to get it back to structural standard to be able to run. And we designed a system called SuperOp 2 to get these back to standard, to be able to do it while in service. If, of course, there's a hole, the hole has to be plugged, and then we get it back to service, right? This system has to be basically it has to be done by trained people. It has to be people have to be trained in the SuperOp 2 system. They have to be certified. They have to pass a pressure test for spools they do during training, and then they're certified to be able to apply the system. So it's a great system, but I had a couple of limitations, which you have to be trained, right? So we looked into, okay, this is a great system, and it's an engineered system. Let's look into using the system in other situations, and we did. So we started calling these type of wraps or patches non-compliant patches. So the system is a carbon fiber, fiberglass, and resin system. Individually by themselves, they're nothing special, but it's like any other type of mixed composites. Once you actually mix them, when you do the certain testing, the the stress versus strain diagram is extremely similar to how carbon steel reacts. So in a way, what you're doing is you're actually adding, in a way, more structural support without having to weld, and this is very important, right? Because this actually gives an advantage and some type of confidence to the asset owner that they're not just putting a patch here, they're not just stopping my corrosion, they're actually giving structural integrity back to the system. So we decided to do non-compliant wraps, where we made estimates of how many wraps would go into a system, not engineered, non-compliant, but it's worked out very well. We've done different jobs. For example, we did a job here in Florida with a gas fire plant, and what they had is in their cooling towers, they actually use fiberglass piping just to limit the corrosion. But what happens is that, of course, they're a lot more sensible to erosion or to basic damage, to stress damage. And they had a leak. When they tried to fix the leak, it was in the piping was underground. They actually hit the pipe while they were trying to excavate it, and they cracked it even worse, right? The asset owner tried using fiberglass and fiberglass bonding. Didn't work. He was really kind of out of solutions. He called us. We went in. We actually it already had a big hole. We did a plate bonding, metal plate bonding on it, and then we went over with the fiberglass system wrap, the fiber and carbon fiber system wrap, and we actually solved it for them. They had already spent $30,000 on looking at other solutions, and we literally solved it for less than $5,000, right? So yep. It's knowing the situation, knowing what products you have to be able to help your customer with the right solution.
Yeah, that's really good insight. And for anyone that wants more information from you or Belzona, as we wrap up this podcast, how can they find it? What are some resources that you all have available for our listeners?
No, that's fine. We have, of course, www.belzona.com. That's our web page. We have www.blog.belzona.com. That's a Belzona blog page. And we have our LinkedIn page. So just search Belzona for LinkedIn. And then for any technical questions, even if it sounds a little bit too weird, just send it to us at technical, right? And that's going to be 3 letters, TKL @belzona.com, short for technical. T as in Tom, K as in kite, L as in long, @belzona.com, and we will always try to help you. And with honesty, we'll tell you if we have something, and we'll tell you if we don't have anything. And I think that's the most honest thing you could tell a customer, right?
Yep, exactly. Folks, this is where we'll wrap up today's podcast. For Alexander Murillo, I'm Ben Dubose, and if you want any more insight from us on our side at NACE before our next podcast, I strongly encourage you to check out nace.org, materialsperformance.com, and coatingspromag.com. Also, if you have not already, please subscribe to the podcast and leave us a 5-star review. As always, thanks for listening, and please come back soon for another new podcast episode.